This video is for Chapter 1, Section 7. If everybody would please turn and open their books up to page 131 and get your notebook ready, we will get started here. Alright, so Section 1.7 involves linear inequalities in one variable. So you are going to see a lot of the greater than and less than equal to, greater than or equal to symbols, because of course those are our inequalities. Back in one of our review sections, we were introduced to this parenthesis and bracket notation to indicate unbounded and bounded intervals. So if you remember, the squared off brackets were the bounded, where you had a beginning and an end. The parentheses indicated unbounded, and in most cases, that it meant that the number itself wasn't included, or it possibly meant that infinity was involved, and we know that doesn't have an end to it. So take a look at the first example that I put up here. If we have squared off brackets for negative 1 comma 3, that would be telling us that negative 1 is less than or equal to x is less than or equal to 3. There's both a beginning and a definite end to that interval, so that is bounded. The second one I put up there, 2 comma 8, notice that there's a hard bracket or a squared off bracket on 2 and a rounded one at 8. So that means 2 is less than or equal to x is less than 8. Again, this is a bounded interval because all of our solutions land between those two numbers. The third one I put up here does have an infinity term in it. So this interval is from negative infinity to 8. So our solutions go in the negative direction for forever and up to, but not quite, 8 itself. That is an example of an unbounded interval. Now, we will be solving some inequality statements, so there's one big thing for you guys to remember. If in your solution step anywhere you divide or multiply by negative 1, you have to remember to turn around the inequality symbol. All right, there'll be a couple examples where we do that, so hopefully you remember that step. So here's our first one. I started us off pretty easy. We simply need to isolate our variable. So let's first get the variable terms together. I'm going to move 2x to the other side. So subtract 2x from both sides. We get 5x is less than 3 on the left and 7 on the right. Now I can move my negative 3, add 3 to both sides. So 5x is less than or equal to 10. Dividing both sides by 5 gives us x is less than or equal to 2. Now graphing that on a number line. With the less than or equal to symbol, that tells us that we're going to have that squared bracket at 2, and then the rest of our answers shade to the left. And it would look like that on our number line. This one, I threw one in that had a fraction coefficient, because you guys love those so much. So let's go ahead and solve this one out. I'm going to move x to the left side, so I'm going to subtract x from both sides. Now, in order to subtract negative 5/3 and negative 1, restate the negative 1 as negative 3/3. Now we get 2 minus 8/3 x on the left, negative 6 on the right. We can then subtract 2 from both sides. So negative 8/3 x is greater than negative 8. Now to get rid of that fraction coefficient, multiply by its reciprocal. Our reciprocal is a negative value, so don't forget to turn around your inequality. And we get positive 3 on the right. If we were going to go ahead and graph this on our number line, less than 3 would give us the parenthesis at 3, and then the less than direction takes us to the left. Solving double inequalities. Okay, if you guys take a look at the example that's on this slide, you've seen this kind of thing before in the past. With a double inequality, you still solve your same solution steps to solving, But remember that whatever you do to that middle part to isolate your variable, you have to do to both sides or both inequalities to balance. So the first thing to get rid of on this one is subtracting 7. Do that on the left side and the right side. So negative 6 now is less than 2x is less than 4. Now we can go after the coefficient 2 and divide it away. Whatever you did there, you have to do it to the left as well as the right. And that gets us here. Negative 3 less than x is less than 2. To graph this one, both symbols are less than symbols. So we have the curved parenthesis at negative 3, curved parenthesis at 2, and our solutions would shade in between. Another topic that's going to be dealt with in this chapter, in this section of the chapter, is solving absolute value inequalities. Remember that there are two solutions to absolute value, one to consider both the positive and negative case. Now, how do you deal with setting that up? First, you're going to isolate that absolute value part. Sometimes you won't have to do that, but in other cases you will, so you'll just have to take a look at it and see. Second, solve the exact situation you see first. After you're done doing that, then you need to set up the other case. What you do to do that is change the inequality around and have the negative of whatever the right side of your inequality was. Okay, so to show you that here with an example, this one actually came number 55 from your assignment set. So absolute value of 9 minus 2x, subtract 2 is less than negative 1. Isolate your variable, or excuse me, isolate your absolute value by adding 2 to both sides. Now we have 9 minus 2x, the absolute value of, is less than 1. Okay, so next thing, you have one situation in front of you because your absolute value is isolated. Take 9 minus 2x is less than 1, the exact thing that you saw, and solve. Subtract 9 from both sides. Negative 2x then is less than negative 8. Divide away your negative 2. X is greater than 4. Don't forget to turn around the inequality. All right, the second case. Now is when you have to consider the negative of the situation that you had in the beginning. So we still stick with the 9 minus 2x, but now we set it greater than the opposite of that right-hand side. And we solve. So negative 2x is greater than negative 10. Divide by negative 2. X is less than 5. Now with these two solutions, the first one says x is greater than 4, so your solutions are higher than 4. The second solution says that x is less than 5. So we have to consider both of those when we give our final answer. Your solutions are going to fall between 4 and 5, and you would write it like this. All right, this is another one that I pulled from your example page because I didn't see an example like it in the instruction piece. So if you look at number 75, it asks you to find an interval on the real number line for which the radicand is non-negative. Remember, if we're going to have real number solutions, we can't let our square roots go negative. Okay, that gets into the imaginary land. So consider all the situations for this as possibilities. If x was 5, that would make a 0 underneath our square root, and we can do that. Square root of 0 is 0. So if it was a 5 itself, we're okay. If x is greater than 5, something bigger than 5 minus 5 will be positive. We can have positive square roots. That's okay. But what if x is less than 5? Anything less than 5, subtract 5, will be negative. Negative roots, not okay for real answers. Okay, so how would we show that with interval notation? Well, the lowest our number can be is 5. And it can be 5 itself, so we use a squared off bracket. Then we can go as high as we want. So that will go up to infinity. And that's what it'll look like. So your assignment, do a few from the early sections like I've been telling you to, but then 83 through 111, I'd like you to do all the odds. Do all of those different situations that they give you in the word problems, at least the odd one, because any and all of them are fair game in that test bank generator. So that way at least you're familiar with them, you've seen them, you've worked with one, and hopefully you would remember how to set it up then on our test. All right, have a good weekend. Talk to you guys on Monday.